In this video, we're going to talk about the planet Mars and sort of just give a broad overview about the basic physical characteristics of Mars and what we know about Mars today. Mars is the next planet out from the Sun. We've been going in order. Mercury, Venus, Earth, Mars. Mars is located about 1.5 times further from the Sun than the Earth. So the distance from Mars to the Sun is about 1.5 astronomical units. Because it's further from the Sun, it receives less sunlight, so it's cooler. Its atmospheric composition is mostly carbon dioxide, which you might think might help to raise the temperature due to the greenhouse effect, but Mars's atmosphere is very, very thin compared to the Earth. The atmospheric pressure on the surface of Mars is only 0.005 atmospheres, so 0.5% of the density of, or the pressure of the air pressure on the Earth's surface. So the air on Mars is very, very thin, but it's mostly carbon dioxide. There's a little bit of a greenhouse effect on Mars, but not very much. Now, in the past, the situation may have been very different. We'll talk about that a little bit later. The surface temperature on Mars ranges from, in the winter near the poles, something like 125 degrees below 0 Fahrenheit, but near the equator, in the Martian summer, it can get as warm as 68, almost 70 degrees Fahrenheit, the temperature of a typical autumn or spring day here on Earth. So it is technically sometimes warm enough on Mars for there to be liquid water on the surface, if the atmospheric pressure were the same as the Earth. It's important to keep in mind that when water freezes and boils doesn't just depend on the temperature, right? It also depends on the pressure. You need air to help hold water down to make it liquid. If I took water and put a bowl of water on the surface of Mars when it was 68 degrees on the surface of Mars, that water would actually evaporate because the air pressure is so much lower. You may know that even here on Earth, if you look at the cooking directions for something that needs to be put in boiling water, like macaroni and cheese, and you read the cooking directions on the side of the box of macaroni and cheese, there are different cooking directions for people who live at a high altitude. Say you live in Denver, Colorado. Why does your macaroni cook differently in Denver, Colorado than it does here at sea level in Virginia? Because in Denver, Colorado, you are a mile above sea level and the atmospheric pressure is less, which means water boils at a slightly lower temperature there than it does at sea level. So while the temperature of Mars is conducive to the possibility of liquid water, the pressure, the air pressure, is not. There's not enough air pressure to hold that water down to keep it in its liquid state. We know a lot about Mars, and we have learned about Mars. We have learned a lot about Mars in the past 20 years. There have been 1, 2, 3, 4, at least 6, 7 successful missions to Mars in the past 2 decades, starting with the Mars Odyssey, Mars Reconnaissance Orbiter in 2005, the rovers in 2011, and the brand new rover, Perseverance, which landed on Mars in 2020. This means that the pace at which we've learned things about Mars is very, very fast. So I'm going to give you a very broad overview of what we know about Mars. I remember when the Viking landers landed on Mars, and I think it was 1976. So I was a little kid when we landed our first space probe on Mars. We have landed many, many space probes and orbited many, many space probes around Mars in the time since. Since we have landed rovers on Mars, we have very clear, detailed pictures of the Martian surface from the Martian surface. And if you look at the Martian surface, it doesn't look terribly different from the surface of the Earth. You see sand and dirt and rocks. The rocks look weathered by wind, which they are. There are winds on Mars. The sky looks different. The sky has this kind of pinkish glow because it's not O2 molecules scattering the light in the air. It is CO2 molecules scattering the light in the air. So the Martian sky has this kind of pinkish glow. The soil on Mars, when you look at Mars through a telescope, Mars appears red. It has the nickname the red planet. The composition of the soil is high in iron oxide, which we would call on Earth rust. And that red color comes from the large amount of iron oxide in the soil. So Mars's sand is sort of rusty. We don't find oxygen in the atmosphere. The oxygen is exist in the presence of oxides in the soil, just like sand on the Earth is silicon dioxide. The oxygen is bound to those silicon atoms. There is ice on Mars, a combination of CO2 ice and water ice, which we'll talk about in a minute. When we look at the whole sphere of Mars, we see that either on the South Pole, if it's winter on the South Pole, or on the North Pole of Mars, if it's winter in the North Pole, are polar ice caps that evaporate in the summer and freeze out of the atmosphere in the winter. So Mars has seasons. The tilt of Mars on its axis is pretty close to the tilt of Earth's on its axis. So when the North Pole is tilted towards the sun, the Northern Hemisphere winter. Northern Hemisphere summer. When the Northern Hemisphere is tilted towards the sun, the ice cap evaporates, and it's cold in the Southern Hemisphere, and that carbon dioxide ice freezes out on the South Pole. The ice caps are largely CO2 ice, frozen CO2. What we would call on Earth dry ice is the stuff we use to, make smoke at Halloween parties and stuff, make a cloud at Halloween parties, is frozen carbon dioxide. So the polar ice caps are largely frozen carbon dioxide, but some frozen H2O water ice as well. Mars has a lot of interesting geological features that I won't go into in a lot of detail, but are worth mentioning. You'll read about them in a book, you'll read about them, or you'll see about them in some of the other videos we watch outside of this one. The largest volcano by size in the solar system is located on Mars. It's called Mount Olympus, or Olympus Mons. It is a dormant volcano. You can see in the cone that it's solid rock. But Mars has no current active geological activity in the form of volcanoes and plate tectonics, which means whenever Olympus Mons was active, it was probably hundreds of millions or billions of years ago. To give you a sense of the scale of Mount Olympus, it is, I think, 300 kilometers from one side to the other. To give you something to compare that to, that is about the distance from the tip of Long Island to Washington, D.C., or if you, I think I mentioned I used to teach in New York, so a lot of my visuals are New York-centric, or the distance from Washington, D.C. to Richmond, Virginia, would fit within Mount Olympus. So Mars is smaller than the Earth, but it's got one of the biggest volcanoes that we know about. It also has got one of the largest canyons that we know about, which is called Mariner Valley, which stretches almost a quarter of the way around the Martian circumference near the equator. When we think about a canyon, we typically think of the Grand Canyon on Earth. Mariner Valley, or Valles Marineris, is about 10 times longer and 3 times deeper than the Grand Canyon. So it is way, 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 way bigger. And the process that created it is very, very different. When we think of a canyon on Earth, like the Grand Canyon, we might imagine that it was carved by flowing water. This is not the case for Mariner Valley. It is not the canyon that is the result of erosion by a river. It is a result of the crust of Mars kind of pulling apart as it solidified and cooled earlier in its formation. I think I might find another video that explains some of the geology of Mars, both Olympus Mons and Mariner Valley, and what we know about Mars's history geologically, or whatever you call geology for another planet. Geo means Earth, right? So the term that we use to refer to geology for other bodies is actually planetary science. Here's a close-up, I think. Next slide, I think, is a close-up of Mariner Valley. The Grand Canyon would fit into one of its small side branches. It is much, much larger and steeper and deeper than the Grand Canyon. We've never landed near or in Mariner Valley or driven any of our rovers there. We tend to keep our rovers places that are relatively flat and safe, because we don't want to spend all that money and time sending a rover to Mars and then have it roll down the side of a crater or into a valley. So maybe sometime in the future we'll explore Mariner Valley in more detail than we have so far and learn more about its history. Even though Mariner Valley was not carved by flowing water the way the Grand Canyon was, there is evidence of past flowing water on Mars. Because I learned astronomy in the 1980s and 90s, will sometimes frame this evidence as maybe, probably, we think there was maybe flowing water on Mars in the past. Someone who learned astronomy in the year 2000 or 2010 or 2020 would probably use more probablys, use fewer probablys, use more certain language than I tend to use. There is very little doubt in the minds of most astronomers and planetary scientists today that Mars in the past had flowing water. We see regions on the surface of Mars that look very much like the sedimentary deposits left at the mouth of a river, say like the delta at the end of the Mississippi or the delta at the end of the Nile deposits sediments in this fan-like pattern. We see sediments laid out in that pattern very similarly on the planet Mars. We see these long channels that look like the paths of past flowing rivers, and they even seem to empty out in what may have been a past lake. So this evidence is pretty convincing. We also see, in addition to things that look like old riverbeds, places that look like, oops, I went one too far, places that look like the sites of former bodies of water. This looks like a lake that used to be filled with water, and the levels, the different levels on the side of the lake bed correspond to where the surface of the water used to be. So for a while this lake was very full and the surface was here, and for a while it was emptier and the surface was there. These look very much like the sides of old lake beds that we would find on the Earth, where the water has dried up and left behind this depression that was clearly once filled with water. Here's another place where that kind of terraced appearance of the side, sometimes it's hard to tell when you look at a picture taken from an orbiter where the high part is and where the low part is. The high part is here. This is like high, and then this is downhill, and this is the bottom down here. Okay, so you're looking down a slope when you look from here down to here, but you can see these kind of what look almost like the boundaries between sedimentary layers on the Earth. If you've ever driven someplace where they kind of blasted away the side of a mountain or a hill and you can actually see the geological strata, well, those geological strata are laid down by sediments, and a sedimentary process requires water. So this looks very much like the side of a former lake bed that in the past in Mars was filled with water. Again, here's another one. Here, this is high, this is downhill, this is low, and the side of this sort of exposed cliffside looks very much like the horizontal sediments we see on the Earth. And again, sedimentary processes are rock that is laid down by the action of water. So there is very convincing sort of geological or Marsological evidence that some of the landforms we see on Mars were created by past flowing water and past standing water. There are also small-scale mineralogical features that look like the evidence of sedimentary processes. First of all, what made this perfect circle on Mars? It wasn't aliens, it was the rover's got like a little sanding disc that it puts on the rock and spins to get the dust and the top layers off so it can do spectroscopy on the layers above. So we made that circle. But we did not make these little balls, these little perfectly round marbles of rock. Here's a view of some of them under the microscope. What would make these perfectly round stones? Is it just erosion from them blowing across the sand? Probably not. We don't see perfectly round spherical. We see smooth stones at the beach. We don't find perfectly round spheres on the beach. But we do find on Earth perfectly round mineral deposits, little rocks that are perfectly round in the desert. And this is a picture of the ground in Utah, and it has these little perfectly round stones called Moki Marbles. What causes these perfectly round stones is sediment that is deposited in bubbles in mud, and when the mud's got a little air pocket in it, and that air pocket gets filled with water, with sediment, and that sediment solidifies, and then the mud washes away, it can leave behind a perfectly round rock. I'm not explaining this very well because I'm not a geologist, but suffice it to say that these perfectly spherical stones, we know on Earth, are the result of sedimentary processes taking place where water is seeping into perfectly round air pockets in mud. Well, you can't have mud and you can't have water without, or you can't have sediment without water. So these little perfectly round mineral deposits are smaller scale evidence that Mars was wet in the past. We also see something on Mars when we do spectroscopy of the surface, which reveals that some of these depressions that we see on Mars' surface are filled with chloride salt. Sodium chloride, what we call on Earth table salt, NaCl. And we see these chloride deposits at the bottom of these depressions on the Martian surface. Well, where do we find a lot of sodium chloride on the Earth? We find it in seas and oceans, right? The oceans are salty. And if you evaporate the water from an ocean, that salt can be left behind on the surface. Do they still do this experiment in elementary school science where you take a pie plate and you fill it with salt water and you leave it out in the sun and the sun evaporates the water, but it leaves behind the salt? I remember doing that experiment in like the 3rd grade. I don't know, maybe they don't do that anymore. But it shows that the salt doesn't go away when you dissolve it in the water. It exists as sodium chloride ions, and if you evaporate the water away, it precipitates back out as sodium chloride salts, and that is our guess as to why there's sodium chloride salt deposits on, and it's not all sodium chloride too, potassium chlorides, other kinds of salts. But chloride salt deposits on the surface of Mars, probably because there used to be a sea or a salty lake there, and that lake evaporated, and that left behind chloride salts on the surface. Here's another as a combination of a photographic image and a spectroscopic image showing that this, what looks like a dry lake bed, actually has chloride salts left behind on the surface. Are any one of these pieces of evidence by themselves definitive evidence that Mars used to have water on the surface? No. But all of these pieces of evidence taken together over the past 25 years have led to a picture of Mars in the past that was considerably wetter and warmer than today. Is there water on Mars now? Well, we know there's water ice on Mars now. This is a crater which was partially shaded by the sun, so the surface temperature of the crater is cold. And thermal measurements with an infrared instrument, I can tell something's temperature, measured the temperature of this ice, and the temperature of this ice is warmer than the sublimation temperature of dry ice. Sublimation is when a solid turns directly into a vapor, right? So if you have dry ice on Earth, it doesn't melt into liquid carbon dioxide, it just goes from solid carbon dioxide to gaseous carbon dioxide. Same thing happens on Mars. So the temperature of this ice is too warm for it to be frozen CO2. So what else could this be? It's frozen water. So we know that the ice caps on Mars have some CO2 ice, but also some water ice. So we know there's water vapor in the atmosphere of Mars, but not enough to account for the fact that Mars used to have lakes and rivers and maybe even small seas. Where could the water be? One possibility is the water is frozen under the surface. There are places on the Earth that if you go dig a deep hole, up in Alaska, in the northern part of Asia, in Siberia, and you dig down 2-3 feet, you reach a place where the soil is frozen. That's called permafrost. It is soil that has got water in it that is frozen solid. And notice these people have stopped digging with shovels and they are now digging with a jackhammer because this soil has got frozen water in it and it is as hard as ice. One idea is that if you went on Mars and dug 2-3 feet deep, you would find the same thing. That all the water that was once on the surface of Mars, or a lot of the water that was on the surface of Mars, has seeped into the Martian soil and is frozen beneath the surface. Do we know this for sure? We do not. We have not dug a hole on Mars deeper than a few inches. We would have to send either a human or a more advanced robot to Mars to jackhammer down 2, 3, 4 feet and see if we actually find this permafrost there. So right now this is only a model for what might be going on underneath Mars's surface. Is there any evidence that there's water flowing on Mars now? Maybe. There are places where we look at a crater on Mars. Again, this is up, this is downhill on the side of a crater, this is the bottom of the crater down here. When we look at some craters on Mars, we see what looks like material flowing down the side, as if water maybe seeped out of the rock here when it was exposed and flowed down the side of this crater. Now you might say, well, didn't you just say a minute ago that it's kind of too cold and there's not enough air pressure for there to be liquid water on the surface of Mars? Yeah, not for long. But look, think about the Earth. Is the Earth hot enough to have melted rock on the surface? No, the Earth rocks are solid on the surface of the Earth. Every once in a while, does melted rock flow down the side of a hill on the Earth? Well, yeah, it's called a volcano. The melted rock leaks out of the inside of the Earth where it's warmer and it flows down the hill, and that's a volcanic eruption. Well, maybe every once in a while, a little bit of melted water will leak down the side of a hill on Mars before it either freezes solid or evaporates into a vapor. Are we 100% sure that this is flowing water? Could it be landslides or something else? It could be, but we certainly see it in a lot of different places. Here's another example where you see what looks very much like rivulets of some kind of liquid have flowed down the inside of this crater. Here's another example, a more dynamic example, comparing two photographs, one taken in, I can't read that on the screen, 1999, and one taken in 2005 by the same orbiting spacecraft of the same crater. And here, in the second photograph, you see this what looks like something flowing down the side of the crater that wasn't there before. This hints at the fact that maybe there is the possibility for occasional liquid flowing water on Mars when underground water is exposed to the 50, 60, 70 degree temperature of the warmest days on Mars. Again, is any of these pieces of evidence by itself smoking gun that absolutely 100% there is water under the surface of Mars or ice under the surface of Mars? No, not by itself. But the sum total of all of this evidence together points to a past for Mars that was warmer and wetter than it is today. Here's another example of a piece of evidence. This might not look like anything but rocks to you, but if you look very closely, there's this perfect square. Okay, I'll highlight it for you. There's this perfect square in the rock. What would make a perfect square in the rock like that? Well, when there's subsurface water and that water freezes, you probably know that water, when it freezes, expands, right? That's why if you put a bottled water in the fridge and it's sealed all the way, that will explode, or leave it in your car when it gets really, really cold in the winter. It will explode because water expands when it turns from water into ice. And the expanding water in two different areas of the soil can, when those regions of expansion meet, cause a perfectly straight line. We see this on Earth. When there's mud that freezes, can make little squares or sometimes even little hexagons where those freezing areas overlap. We can also see it on a bigger scale. Here's a picture of Mars, and this appearance of these lines where the frozen soil is coming together and meeting at a point looks very, very similar to places where there's subsurface ice on the Earth. So again, by itself, is this evidence that there's ice under the soil of Mars and that's where the water went? No, not by itself. But all of these things taken together have given us a very, very convincing picture that there was past water on Mars. I'll give you one more example. This one, I don't think many people believe this one anymore, but this is, it's another little tiny piece of evidence of the possibility that there's some water in the soil. This is an artist's conception, a painting, drawing, visualization of a lander called the Mars Phoenix lander. We land stuff on Mars in all sorts of different ways. Sometimes we use parachutes. Sometimes one of the rovers was in like a big bouncy ball that just kind of bounced along the surface. Or we can also use rockets to slow the descent of a lander so that it lands softly on the surface. That's what the Mars Phoenix lander did. And when a lander lands on another planet or moon, one of the first things that NASA usually has it do is to take a picture of its own feet to see if maybe it landed on a rock and is tilted funny, or one side sunk into some sand or whatever. So these are the feet of the Mars Phoenix lander. I'm sitting very firmly in the soil. Nothing unusual happened. But if you look really, really closely at the struts that hold the feet to the body of the lander, there are these little tiny, perfectly spherical, shiny, what look like droplets, as if maybe as the rocket engines, as the lander descended and those rocket engines heated up the soil, evaporated some water ice underneath the dirt that then condensed out into droplets on the landing struts. Are we sure that's what happened? No, we're not sure that's what happened, but that's certainly what it looks like. So again, lots and lots and lots of little pieces of evidence, and these little pieces of evidence have been growing more and more convincing over the past 2 decades as we have orbited and landed now dozens of spacecraft around Mars and on Mars. This points to a Mars in the past that would have been very, very different from Mars today. If there were rivers, well, if there were lakes, then there had to be enough of a atmospheric pressure to keep those lakes from evaporating. So if Mars had lakes in the past, it had to be warmer, but it also had to have had a thicker atmosphere. You can't have, even if all of Mars was 80 degrees today, water would still evaporate on the surface because there's not enough air pressure holding that water down. So Mars in the past had to be warmer and have had a thicker atmosphere. If there were rivers on Mars, and we saw evidence of what looks like flowing rivers, there had to have also been clouds and rain, right? That's where rivers come from. Rivers don't just flow forever, they would empty out. What makes a river flow is rain falling on mountains and hills that runs downhill and runs to the riverbed and then flows down to a lake where it evaporates again and makes clouds. And so Mars would have had a thicker atmosphere, an atmosphere with clouds, standing water on the surface, and probably with a thicker atmosphere, a higher global temperature than it had today. So 1 billion years ago or 2 billion years ago, Mars may have looked more like the Earth than it does today. That raises a really, really interesting question, which is what happened? If Mars 2 billion years ago had lakes and rivers and clouds and rain and a thicker atmosphere and warmer temperatures, why is it now a cold desert with no liquid water on the surface, with a very, very thin atmosphere? And what changes could have happened to Mars that caused that? I'm going to leave that question open for now. We'll either address it in a separate video, or I will give you an assignment to do some research and find out what are our models, our theories, our ideas for what could have happened to change Mars from the warmer, wetter place that it was in the past to the Mars that we see today.